Hi there, welcome to this video where I'm going to talk about this mini spot welder that you can use to do spot welding. And these are available on eBay and other sites. They have a few downsides to them which I'll also discuss. The job in hand was to refurbish these eye buttons. Now you often see these used to log into tills in shops such as Weatherspoons. But our particular use is the ones that work as temperature data loggers. And this particular variant of them has a battery inside. And after about 10 years they all start to die because the batteries are dying, which is a shame since the higher capacity data loggers are about £60 each. So I thought I'd open some up with the idea of changing the battery. And the easiest way to open them up is to cut the bottom, this flanged bit, off the can. Now the other challenge was how to connect wires to them, because I didn't want to rely on wiping contacts with the can, since the SRAM contents are lost if there's any disconnection of the battery, even for a very short period. But you can't solder to these cans because they're made of stainless steel, so I needed to connect wires to them in some way. Well, my first attempt was this conductive glue that I bought on eBay, and this comes in a syringe. But this wasn't successful since the contact resistance when you glue the wire on is about 150 ohms, which is far too much. So my second idea was to spot weld onto the can, take some nickel strip and spot weld it on, and you can see this has been successful in this attempt. I've got a bit of nickel spot welded to the bottom of the can and a bit to the side of the can where I need to make the other content. And once you've done that, you can actually solder to the nickel. It takes solder, unlike the stainless steel. Now, how do you do spot welding? Well, you either have to buy an expensive spot welding rig for a few £100, or you can get one of these on eBay for £15. And essentially what this does is it takes a high powered battery, such as a small car battery or a golf cart battery, or one of these high powered batteries that are used in remote control racing, and it short circuits it through the spot welding probes in a controlled manner, so it makes sure that short circuit only takes place for a few milliseconds, and hence you're not in too much danger of blowing the battery up. Now I've assembled my rig here, and I've done a few modifications to this as per other videos online. There are a couple of design flaws with this particular device. Firstly, if the battery voltage drops, as it's likely to do when you put a short circuit on the battery, that cuts off power to the control module, which potentially means that you lose control of the MOSFETs, which switch the high current, and this leads to the MOSFETs burning out when they're in a quiescent state. Now this problem is worst if you've got an underspecified battery, or your battery's low in charge, and the display does actually tell you the battery voltage when it's turned on. And to get around this problem, we solder two 470 microfarad capacitors in parallel across basically the input power powering this control module. And this modification can be found online, and you solder the capacitors between the output of diode and ground on that board. Here you can see the control board removed with the two 470 microfarad capacitors soldered in place. The positive leg is going to the diode, which is shown by the left hand finger, and the negative connection is to any ground point as indicated by the right hand finger, and another one further up above the diode. The second modification I've done, I don't know if this is strictly necessary, but it's to beef up the high current tracks on the bottom board. Oh yes, I should say that there's several versions of this device floating around on eBay, and you don't really know which one you're going to get. This is the earlier design, which allegedly is better designed and is before they've tried to do cost reduction. And in this design, all the control circuitry is on the top board, and the large capacitor on the bottom board is simply to bolster the supply from the battery. The later designs have a lot less control circuitry on the top board, have a bit of extra circuitry on the bottom board underneath that capacitor, which this hasn't got, and they repurpose that very large capacitor to do the job of the ones I've soldered in, and it's no longer doing its original purpose of bolstering the battery for the welding operation. And that later variant is supposed to be a bit of a bodge really, and not a great design at all. But the other modification I've done is to beef up these high current tracks by soldering large lumps of copper wire along them. And here we can see the bottom board removed with the beefed up track along the negative, from the negative terminal along the MOSFETs, and also from the output of the MOSFETs to the negative probe terminal. Also, as per another suggestion, is that I haven't used this positive track, which doesn't really do anything, it just connects that terminal to that terminal. I've just connected the battery and the output positive probe to the same terminal, so I'm not using this track here. Then I needed to find a high current battery connector, and I went a bit crazy here because I bought this 175 amp Anderson connector off Amazon, not having seen how huge it is. And it is really massively overspecified considering you're only going to be drawing that high current for a very short period of time. I also over-egged my battery specification rather. The instructions state that you need a battery of up to 6 amp hours 60C. Basically you multiply the amp hour and the C specifications together to get the peak current. So that would give you 360 amps as the peak current, whereas mine's 5.2 amp hours and 80C, which will give you a peak current of just over 400 amps. So slightly over specified, but should be okay. Seems to work all right. To charge the LiPo battery, I just got this rather cheap LiPo charger, or multiple battery charger. So if it's selected to be a lithium battery, then you can do what's called a balance charge, which uses a small connection on the battery to monitor the voltage of each cell, which you can plug into the 3-cell connector there. There are various connectors for different size batteries with different numbers of cells. And this is my outrageously big connector to connect my battery onto. And it seems to work okay. Hasn't blown the battery up yet. If we power up the device, nothing happens, and that's because you have to press this on-off switch under here that starts the power to the control circuitry. Some people say they bypass that, but I've left mine in. And then it comes up with this display on the organic LED display. It tells you what the weld energy is set to, and it's 10E at the moment. That means it's about 10 milliseconds welding time. I'm going to take that down to 5. Lots of people crank it right up, and that increases your risk of burning your MOSFETs out. And then under weld way, it says auto at the moment. I'm going to put that onto manual. Whoops, press the wrong button. You press the square one to change the welding method. So I can change that to manual, and that means it will weld when the connections across this foot switch connector are shorted out. The auto weld way automatically detects when the probes are connected together and gives you a beep and then does a spot weld. Well, I'm not quite confident enough to use that yet, so I've left it on manual. Then you'll see also under input it tells you what your battery voltage is, 12.4 volts here. For my foot switch to control when I'm going to do the weld or not, I've just made up an adapter to a jack socket, and then I'm using this piano sustain pedal, which I happen to have around. This is a universal one, so it's switchable between being normally open or normally closed. Obviously for this application I want it normally open, so it closes the contact when I press the foot switch. I should say that I probably get away with only using 5 milliseconds of welding, because I've got a pretty high powered battery and I'm trying to weld something pretty small, whereas other people have to go up to 40 or 50, probably because they've got a small battery and they're trying to weld something a bit bigger. Okay, so I'll just do a demo weld for you here. I don't know if the insulating gloves are strictly necessary. It's like difficult to hold things. You hold your probes down onto the metal at an angle and a couple of millimetres apart. Then I press my foot switch and the machine should beep a couple of times and then do the weld. Of course, make sure my probes are nowhere near the edge of the can or they'll just spark across to there as well. So there we go. The probes slightly stick to the metal, they slightly weld themselves down onto the nickel strip. You can see the two little indentations where it's welded through onto the can, and that is securely welded in place. I can't get it off. You might want a bit of a deeper weld if you're going to make up battery packs, which is the main use of this technology. But this is just going to be sitting in there and it's all going to be potted in araldite eventually, so I'm not too worried about having massively deep welds, and I don't want to burn through my can where it's got nice serial numbers and things written which are useful. And then I would just spot weld another piece of nickel onto the side as the other contact. That's the data contact on that middle part of the I button, and then the outside of the can is ground. So I think I've covered most things that I've seen in other videos. I'll just have a quick look through my list and see if I've checked everything. The supply voltage to the board is nominally 12 volts, and this is an 11.1 volt LiPo, so that's fine. If you have too big a battery, if you really over-egg your battery, like use a large car battery, it might be the current spike might be too much for the MOSFETs to handle and you might burn them out. Keep your high current wires as short as possible or you'll have losses in the wires. So you notice these are the wires that are provided. They go through this high current connector, and then I haven't extended my battery wires either, which makes it all a bit tricky because everything has to be close together, but does the job. I have got another welding probe which I haven't tried yet, which is automatic. I'll show you that. So I have seen this successfully used in other videos. It's got two sprung loaded probes, and they go through. There's your high current connections there and there. When I first got it I thought, what the hell's going on here? Surely I'm not going to have high current go through that silly wire. But that wire, the thin wire, which I've put a jack plug on the end, is actually connected across that micro switch. Again, I thought, what the crazy thing, I can't have high current going through there. But when you push this probe down, it closes that micro switch, which is going to trigger the weld. So the idea is you plug that into the weld switch on the thing when you're on manual mode. Put your welding probes down, push them down, and when that switch closes, that will trigger the manual weld. I think I'm happy with my manual probes actually. They seem to be working pretty well straight off. So yeah, I'm not planning on really trying this out. It looks a bit weird there. They're very close together, those two. You could get arcing across there instead of through your probes, I would have thought. Maybe some insulation down there would help. Anyway, thanks for watching. I hope you enjoyed this video.